Hello dear viewers, I am your design and technology teacher Mr. Ramdhonee, and this video is on grade 9 chapter 6 mechanisms. So let's get started. So the learning objectives are as follows. After watching this video, you should be able to state the functions of mechanisms, identify the different mechanisms in machines, and assess the use of components in systems design. The chapter can be summarized as such: types of motion, functions of mechanism, and mechanical components. We are going to go through each of these. Before we embark into explaining what is actually a mechanism, let's have a look at the different examples of the mechanisms. So we have the paper hole puncher, the scissors, can opener, our bicycle, DVD player, clock, home gym, the car engine. We also have the stapler, the fan, the excavator, the ratchet tool, the guitar, the tap, the elevator, or the car jack. And these are only a few. There are many more out there. To understand mechanisms, first we have to understand machines. So what is a machine? A machine is a device used to make work easier. Therefore, the mechanism in that machine is used to control or transform movement. In other words, input motion is converted into output motion through mechanisms. For example, for a bicycle to go forward, the input motion will be the force you apply on the pedals, and then to transmit the force to the wheels, mechanisms are used. All mechanisms have the following in common. They involve some type of motion, they involve some type of force, they make a job easier to do, they need some type of input to make them work, and they produce some type of output. In the next segment, we are going to look at the types of motion. So basically there are four types of motion. The linear motion is motion in a straight line in either direction, from left to right or from right to left. It can also be from top to bottom or bottom to top. Rotary motion is on only two directions, either clockwise or anti-clockwise. For example, when the wheels of a bicycle they turn either clockwise or anti-clockwise. Same goes for the clock. The clock moves in only one direction, which is the clockwise direction. The reciprocating motion is a repetitive up and down or back and forth linear motion. The oscillating motion or oscillatory motion is defined as the to and fro motion of the body about its fixed position. It is a type of periodic motion. So what are the purposes of mechanism? They are used for 6 basic tasks. The first one is to change the type of motion, for example, from rotary to linear. The second task is to transmit movement from distance. For example, when you're driving a car, when you turn the steering wheel, the wheels in the front they move. So the steering wheel is connected to the axle of the front wheel. Here, the movement is transmitted from a distance. We can also change the speed of movement. For example, in a bicycle, the pedal gear is larger than the sprocket. So when you apply force on the pedal, this turns the sprocket, and in turn that turns the wheel. So you can change the speed of motion through the sprocket. The fourth one is to amplify or to reduce distance of movement. In this example, a pantograph has been used where you see the initial shape is a small circle to have a larger diameter. So the fifth one is the change of movement. When using a handrail, this can be seen easily. And the last one is change amount of force a movement provides. For example, using a thin snip to cut metal sheet. Next part is mechanical advantage. Mechanical advantage is a measure of force amplification achieved by using a tool, mechanical device or machine system. In other words, it is a measure of the ratio of output force to input force in a system. Therefore, the advantage gained by the use of a mechanism in transmitting force is called the mechanical advantage. So mechanical components are parts which are subject to forces which run a machine. So what are these mechanical components? We have the lever, we have the gear, we have chain and sprocket, we have pulleys, we also have linkages, cams and screws. We are going to look at each of these examples in the next part of this video. A seesaw is a good example of a lever. The lever will have a fulcrum, which is also called the pivot, onto which there will be a load, and in order to move that load you need to apply a certain amount of effort. There are three classes of levers. The first one is class 1, where the fulcrum or the pivot is at the center and then the load is at the bottom. The effort you have to put it from the top. For example, when you use a combination plier, the load is between the jaws of the combination plier and you have to put effort at the handles. Same goes for the scissors. Class 2 lever is when the fulcrum is at the end of the rigid rod. The load is at the center and the effort is being done at the end. For example, a wheelbarrow. You have to lift the handle and the load is at the center. Another example is the bottle opener. Lastly, class 3 is when the fulcrum is at the end, the effort is at the middle and the load is at the end. For example, a stapler. And you also have a fishing rod. These are examples of levers which have been classified according to their class. Class 1 we have seesaw, pliers, scissors, crowbar, plow hammer. Class 2 we have wheelbarrow, bottle opener, carbonet, nutcracker, car door. Class 3 we have stapler, fishing rod, broom, sugar tongs and biceps. A pulley comprises of a wheel on a fixed axle with a groove along the edges to guide a rope or cable. Pulleys are used to reduce the time and energy taken to lift heavy objects. So when we talk about pulley, we have to mention velocity ratio. So speed can be increased or decreased upon changing the diameters of the pulleys used. Examples of pulleys are as follows. We have water well, we have window blinds, we have the crane, the flagpole or even the elevator. The next type of mechanism is the chain and sprocket. This is commonly found in bicycles, in motorcycles and many other types of machines. The teeth on the sprocket prevent the chain from slipping. Due to the friction that is occurring on the chain and the sprocket, the mechanism must be lubricated with grease or oil to prevent damages. Gears are used to transmit mechanical power, and gears may also be combined to change speed, motion or force. They are commonly found in many different types of machines. Let us have a look at the types of gears first. So we have the gear train, we have worm gear, rack and pinion, bevel gear or spur gear. The table shows the description for each and its application. Linkages are used to transmit force and movement in a mechanical system. Linkages are essentially bars or rods which are linked together. Application of linkages are as follows. You have a toolbox, locking pliers, lazy tongue pop rivet gun or car wipers. Cam is a mechanism which converts rotary motion into linear motion. We need a cam and a follower, and you can see the cam profiles which are as follows. The pier, the circular, the hard and the drop. Examples of the application of cams are mostly in toys, A screw is a mechanism that converts rotary motion to linear motion. Screw mechanisms are known to increase input force. Examples of the application of screws are a G-clamp, the screw lead on a center lathe machine, or a car jack. We have finally reached the end of this video. I thank you for your attention, and if you have any questions, feel free to send me a message on my WhatsApp number. Please like, share and subscribe. If you found the video useful, consider sharing it with a friend. See you soon and take care.